What's up guys, my name is Ajit Menon from Tech for Life. Today I'm going to cover some important topics related to engineering mathematics. This, as you can see, linear algebra, calculus and probability. These are the topics we are going to cover in this tutorial. So these topics mainly comes up to 7 to 10 marks. So, and trust me, it's very easy to score. So in this lecture we are going to see some properties related to linear algebra. Okay, mostly the gate question comes from these three: eigenvalue and eigenvector. Then they will ask the solution is unique, no solution, or infinite, and at last they will ask the rank of matrix. These three are the popular questions comes in gate, and at least you can expect a 2 marks from this section. So these are some important properties we're going to cover. So this you must write it down somewhere. Sum of diagonal is equal to sum of eigenvalues. Product of determinant is equal to product of eigenvalue. These two properties are very important in solving gate questions very fast. So just remember these two properties. So we will use this many times in our tutorial. Let's start with our first example. This question was asked in 2005 gate examination. So in this question we need to find the eigenvalue. So by using that property, sum of diagonal, 2 plus 5 equal to 7. So we must find the option such a way that addition of that will get 7. So by seeing this option, this value will get 0 and this 7, and this also we get as 7. So A and D are not our answer, so it must be B or C. So now to take the determinant of these matrices, that will come to be 2 into 5 minus 4, 6. So remember the second property, multiplication of two eigenvalue will get the determinant value. Option B only matches, so our answer is B, 1 and 6. This is how we solve the gate question. Second question, this was asked in 2006. So in this example also we need to find the eigenvalue. So we can see by option, all option matches 3a, which is our diagonal sum, 3a. So we cannot use our first property to get our answer, so we will use our second property, that is, first we need to take the determinant of these matrices. So let's do that. Minus 1, a is equal to 0. Okay, so this is our, so expand in this we'll get, so it's a, so we'll get a cube minus a is equal to a cube minus 2a. Okay, now we'll see our option. So option B we will get a cube if we product this, and in option C, so you can see we will get a 2a cube, and here also something around minus 4a cube. Okay, so our option A only matches. We will solve that, product as option A. We prove it matches. Okay, so this is like a minus b, a plus b. So that formula we know that a square minus b square, so that will become 2. So if we solve that, we get a cube minus 2a. So that's our answer. So our option A is correct. Okay, this question was asked in 2015 gate examination. So here we need to find the eigenvector, okay, corresponding to eigenvalue 1. We know the characteristic equation of eigenvector, that is a minus lambda I equal to 0. So using this we will solve that. So we could directly write like this. Okay, since our lambda is 1, we will get all these diagonal, sorry, here also 1 minus lambda, all these diagonal lambda as 1. So 1 minus 1, it will become 0, and here also all diagonal will become 0. So our new matrices will look like this: 0 in all the diagonals, and here minus 1, 2, 0, 0, and 1, 2. So okay, so our equation. So by we can see, we can create an equation for this, that is minus y plus 2z equal to say 0, 0, first equation, and here all elements are 0, so we do not see that, not take into the account. So directly we can solve the third, that is x plus 2y equal to 0. So these are two equations, x plus 2y equal to 0. So x equal to minus 2y. Suppose we put x value as k. Okay, we put x equal to k. So what will be our y value? Y becomes minus h by 2, which means that minus k by 2. Okay, similarly we have other equation, which is minus y plus 2z equal to 0. So 2z equal to y, and we know that z equal to y by 2, and we already know y value is minus k by 2, so it becomes minus k by 4. So we have all three values. So what? X equal to k, and y is equal to minus k by 2, and z equal to minus k by 4. So we could write like this. Okay. But see our option, neither of them matches, so all are in not in fraction form. So what we need to do is we need to multiply by 4. Okay, so what we'll get is 4, then multiply minus 1 by 2 into 4 becomes minus 2, and here becomes minus 1. Still it's not get matches. So but see here, when we multiply again by minus 1, we get our answer. See, option B matches. So in this way we need to solve the gate question. This question was asked in 2016 gate examination. So it is given that the matrix P is a real matrix, but one of the eigenvalue is an imaginary term. We know that root of minus 1 means I, that is a complex term. So and here we already given two eigenvalues. So third must be a complement of this, because we need to have that what, real matrices. That's why the third eigenvalue will be complement of this, so that we get the resultant as a real value. So okay, so our three eigenvalue now will look like, and 2 minus I. So this is what our eigenvalue look like. Now we know the properties. We are asked determinant. So we know that the product of eigenvalue is equal to determinant. Okay, so we will product this value 2 plus I 2 minus I into 3. So this becomes 4 minus I square a plus b a minus b formula, and this becomes 3. So minus I square, we know that this is minus 1, so we could write like this. So becomes 15. So that's our answer. So thanks for watching. Do subscribe, and if you have any doubt, please comment below.